We are trying to subtract rational expressions. Notice the denominators are different. Here we have x minus 3 and here we have x plus 5. They are different. If the denominators are different, we need to find common denominator and convert the given rational expressions into the ones with the common denominator. So to explain the basic idea, I'm going to give you a little numerical example. Let's try to add 1/2 and 1/3. See, the denominators are different. How do we add these two fractions? Well, what we're going to do is to multiply the first fraction by 3/3 and multiply the second fraction by 2/2. So 3/3, that is 1. Multiplying any number by 1 is not going to change the number. Multiplying 1/3 by 2/2, 2/2 is 1, so multiplying 1/3 by 1 is not going to change 1/3. So this is still a half plus a third. But in this way, if you write it this way, you see, if you look at the denominator, 2 times 3, that's 6. And 3 times 2 here, this is also 6. And just compute the numerator, this is 3, and 1 times 2 is 2. Now look at the results here. We have 6 and 6, we have now the same denominator, right? So where does 6 come from? Well, 6 came from the product of the two original denominators. 2 times 3 is 6. Now we can finally add up the fractions. Since now they have the same denominator, just add up the numerators and get 5/6, and that's the answer. Okay, now we're going to apply the same idea to this problem. We're going to multiply the denominators x minus 3 and x plus 5, multiply them to get the common denominator. Just like we got 6 here in the numerical example. 6 came from 2 times 3, the two denominators. Okay. So let me get this numerical example out of the board. Okay, now we have more space. Let's work out this problem. So we're going to multiply the first expression, 2x over x minus 3, by, we're going to multiply this one by x plus 5, x plus 5. And then subtract the second expression, x over x plus 5, and multiply this one by the denominator of the first expression, x minus 3, and x minus 3. Okay, and we multiply numerators together and denominators together. And once again, remember that if you have more than one term, and if you multiply them, you have to put parentheses around the terms. Okay, the numerator we have 2x times x plus 5. In the second fraction, we have x plus 5 times x minus 3 in the denominator. And notice that this is the same as the denominator of the first rational expression. And on top of the fraction, we have x times x minus 3. Okay? So let's draw one big line and put this common denominator once. And let's subtract the numerators. 2x times x plus 5 minus x times x minus 3. Okay, now we're going to simplify this expression and then we're going to be done. Okay, so we have x minus 3, x plus 5, just copy it over. And then we're going to expand this everything out. So distribute 2x. And then we're going to get 2x times x is 2x squared plus 2x times 5 is 10x. And then subtract the product of, we have to multiply negative x by x and negative x by negative 3. And that's going to give you negative x squared first, and negative x times negative 3 is positive 3x. Okay. And if you simplify the expression, we have combined like terms. 2x squared minus x squared is x squared. 10x plus 3x is 13x. And in the denominator, we have x minus 3 times x plus 5. Okay, so let's see if we can reduce this any further. In order to reduce any irrational expression, we have to factor everything out. So let's look at the numerator. The denominator is already factored, so let me just copy it over first. Then factor the numerator. This x is a common factor, so factor it out. X times x plus 13. So now we have 4 factors: x plus 13, x minus 3, and then x plus 5. And they're all distinct factors, so there's nothing to cancel out or anything. So this is the final. This is going to be the final answer.